You can, for example, put an existing list inside this list, or you can actually query right out of the database and place it in that list. But if you don't want to do that and you want to start a brand new list for whatever reason, you actually need to tell Apex, hey, this list is going to be a new list. And that is the right side of this equation, is saying it's a new list of type string. And those two sides, the list and the type of data type that is in that list must always match each other. So I can't say list string on the left side and use list integer on the right side, because it will give us an error saying that data types don't match. Once we identify that we want to create a new list, there's a couple options, and one of the options is what Luke is showing here, which is actually providing the values of this list. And with that, I'll hand it back to you, Luke.
All right. And so this list is a list of the data type strings. And that means if I'm putting anything in it, it has to be a string. And so in Apex, strings are always enclosed in a pair of single quotes. So this first item I put in is rope, and then I put in twine. But now I've got something different here. Here I have some word. Well, if we look back one line, you can see that previously I defined just a string, and I gave that string the variable name of some word, and I populated it with the text of thread. So the list can accept either direct input of text in single quotes, or it can accept other variables that are also strings and include them. And that gives you a little more flexibility to define what you are moving around with. So the next thing we're going to take a look at, now that we've got our first list here, is how we can do things with that list. And as we've seen before with data types, there are a lot of methods that we can apply to different things in Apex. And methods are like the pieces that we encounter when we're creating formulas or workflows, where we have that list of functions that we use to make things all uppercase or lowercase, or change it in various ways. And all of these are referenced in the documentation. So let me pull that onto the screen here and switch over to list class. This is the Apex Developer Guide, and this is specifically a description of the list class. And it gives us a little bit of information about lists at the top. And if we scroll down a little bit, we pretty quickly get to the list methods. And these are elements that functions that you're going to apply to your lists all the time. You're not going to remember them all, so you will frequently be coming here and looking at this to find how you can do cool things with your lists, so that you don't have to create really complex ways to figure out how many items are in a list, for example. And if we look back on our developer console here at line 12, that's exactly what we're doing here. So I'm referencing our list by its variable name now, 3 strings, and then using dot notation. Using dot notation, I prepare the list to accept this method, the size method. And because it's a method, I have to put a pair of parentheses after it. And when I put these all together, that means that Apex, when it runs this, is going to tell me how many items are in that list. I'm doing this here in a unit test so that we can run the test and get some confirmation that we have things correctly done. And I'm using this system assert equals command, which will accept 2 things. First, it'll accept what I expect the size of the list to be. And then it's going to take, again, what I just detailed was the way that we use the size method for lists to define the size. And if I were to run the test now, I can see the test passed. I got my nice green check. And if I were to go into the logs, I could actually see that the size had output that there are 3 items in this list, and that therefore it equals the 3 that I expected. And we'll be taking a look at some other list methods shortly, because the next thing I want to describe about lists is the concept of index numbers. So we already said that lists are ordered, and that means every item is assigned a numeric value so that we can reference it without actually knowing what's at that point. So here I once again reference 3 strings, and then in a pair of square brackets I enter a 0. And that means it's going to retrieve the item in the first place, the 0 index of our list. And again, with my assert equals, I had said I expect that to be rope, and that will, and by choosing the 0 element, it's going to make those two halves of the assert equals actually equal. And then if we wanted to do something different, if we wanted to check the second one, we could simply do the same thing, system assert equals, and I get this nice completion, auto-completion. And if you look at this here, you can actually see it giving you some clues that the first thing I need to put in is I can pretty much put anything in. That means, by that it means any data type. And it's saying that this is the expected value. And then once again, I can put in any data type, and it's what will be the actual value. It's very useful to keep those two items consistent because the error output, if you get it wrong, will tell you this is what you expected and this is what it actually is. And if you don't want to confuse yourself, it's best to keep it that way. We'll do a little example here that shows what it looks like when it doesn't work, and then we'll make it right. So I'm going to mistype my expected value and call it twin, and say that I want to see what the value at index 1 is. And I'll save this and run the test. And I get the angry X of a failed test. If I double click on this item, it's going to open a new screen and tell me what went wrong with my test run. And here's the error reported. And it's telling me you expected it to be twin, but it's actually twine. And the actual means that's what's actually in the list as you returned it.
I'll make a quick comment here. What Salesforce is telling you in the log is what you expected, and what the actual is purely related to where you put it in the assert equal. So if you switch your string in quotes with your variable, in other words, if you put the variable first and then the string second, it will tell you you expected twin and you got the actual is twine. So in other words, all it really tells you is, hey, on the left side it was this, on the right side it was that, and they have to match. And the reason I just figured it's important enough to mention is because if sometimes you confuse those two, and then you try to debug and you read the log and it tells you, hey, you expected this and you got that, it could be because you switch them. It would still indicate that something is wrong, but just the wording of expected versus actual, just important to understand that when it says, hey, you expected it to be, it actually just means that's on the left side of it. I hope that I made sense and didn't just...
Yeah, I'm taking pains to show this because when you start debugging, you're all of a sudden in this whole new world of confusing things, so we definitely want to try and alleviate as much of that as you get into Apex. The next thing I wanted to also point out is when we looked at that autocomplete, it said the data type could be any data type. Well, that's true. I can put a number in here. I'll put 192. just a plain old integer. And it's going to save. And, well, actually, no, it's not. That's good. Actually, this is even better. It's telling me that my comparison arguments, the two items in the assert equals, must be compatible types. So even though that autocomplete said it can be any, they actually do have to be the same data type. That just changed it to text. And of course, we know that if I were to run this, well, 3 strings, the thing at index 1 is actually twine, and therefore this system assert would not pass. So for the sake of moving along, let's try and get that right. And move along here. So now we are going to take a look at another way to create a list, and that's a list that doesn't have anything in it. And this is actually probably what you'll do more often. You'll end up creating a list that you're going to populate a bit later. And the way you do that, well, of course, you start with the same initial portion where you say, I'm creating a list, and in angle brackets, you tell it what data type. So this is a list of strings again. And you give it a variable name. I called this one no string, since we know that there's not going to be anything in it. And then as Ohad was explaining earlier, we do have to tell Apex that this is a new list and it's a list of strings. But when we want to create an empty list, we just use a pair of regular parentheses. Previously, we had used curly brackets. Here we just use parentheses instead. And this is just one of those things that you sort of learn to, well, you either learn or you, by trial and error, get there, because there are only so many types. I've certainly tried square brackets and gone, no, that's not it. So it's one of those things you'll inevitably forget, but if you look around or reference back to this code, hopefully you'll be able to go, oh, I need some parentheses. Because if you don't have them and you try and save it, it's going to throw you an error that's not quite so helpful. It just tells you unexpected token. It tells you that's on line 19, and essentially when you get a message like that, it's the way the compiler says, as it was going through this string, it got up to that semicolon, and it didn't expect it. It expected something before it. So that's a clue you can get that something must be missing right before that. And in this case, it's those parentheses. And then on the next line, I do a slightly different version of our assert. And this is instead of an assert that is expecting 2 things that it's going to compare, like we did previously, this is an assert that simply is expecting a true or a false. The system assert is used with Booleans. So I could do something as simple as, say, true in here. And if I were to run the test, that makes the system assert very happy because it wants whatever's in there to be true. We can see that recent test run passed. But we're trying to check and make sure that our new list here, no strings, is in fact empty of all items. And there is a convenient list method for that. This is empty. And our autocomplete even tells me it's going to return a Boolean. So I'll go ahead and double click that, and it chops that right in. And I'll go ahead and save again. And when I run the test, I know that because it went through this system assert, that it must have worked, because otherwise it would have thrown an error. And we are going a little off list here and also talking about unit testing methods, because you do a lot of unit test writing in Salesforce. So along with specific topics like collections, I'm also trying to give you some information about the other things you'll be doing. And one useful thing with Booleans, as you probably know from creating formulas, you can reverse them. Now, in formulas, we would use not to reverse whatever we have. However, in Apex, we just use an exclamation point.
You can actually, just in case anybody's interested, you can actually use exclamation in formula as well.
Yeah, I thought you might be.
But in Apex, you have to use exclamation. You can't use not.
And by putting that in front of it, well, now I've reversed my Boolean there, and now that test fails because I turned the true to a false. So there's not a while there is a variation on the assert equals of assert not equals. Asserts just have their basic assert, and you have to provide the not in there. And now we're going to take a look at another way that we can populate the list. So instead of the way we started, where we just directly put things into the list, here we're going to add things one at a time. And I do that by starting with reference to my list, no strings, and again go with dot notation to say I'm about to do something to this list. And what I'm about to do is use the add method, and I'm going to add the text rock. And then I do a system assert to confirm that now the size of that list is 1. And so we have our first practice here. I'm going to go ahead and walk through this. You're certainly welcome to walk through this on your own as well. But we'll also, if you want to watch and learn and do the practice later, we're going to review this at the top of the next session. So the instruction here is using the values in the first list we made, that was the one called 3 strings, you have to uncomment these 2 lines below and get the unit test to pass. So we've got one example here that's already uncommented, and that is a system assert equal that's checking that the item at index 0 is the text rope. So now I'll move on, uncomment that one, and now we have that we're actually returning the item at index 1 from that list of 3 strings. So if I were to look back up at that list up here, I can see that here that's index 0, this is index 1, and that's twine. Go ahead and copy that and put that in there. And then for our next practice here, we sort of have the reverse. Well, we provided what we expect. We expect it to be thread. Now, we know what's in this list, but just to go back and take a look, we're going to say, well, wait, there's something different here. It's that some word. Oh, yes, some word was a variable we defined, and that is indeed thread. So it's just like that text thread is in there at index 2. So I'll go ahead and put a 2 in there. Save it, and we'll go ahead and run that test, and we get the friendly green arrow, or the green check mark down there in our test runs. And now we'll go ahead and move on, and we'll get something a little more complex here. And I think Jonathan was talking about the embedded lists a little earlier. So now we're looking at lists of lists. So we were previously putting a data type of just strings in a list, and you can put pretty much any data type into a list. You can put integers, you can put booleans, which would be a pretty boring list of just trues and falses, but you can also put other lists inside of lists. So if we were to decode this code, we might start on the inside and say, well, here we have what we're familiar with already, a list of strings, but then we have that list of strings here in another list. And this is pretty common. You run into this and you don't even know you're running into it in Salesforce a lot. But if you think about like looking at an accounts and contacts report, Well, you're really getting a list of all the accounts, and then for each account, you're getting a list of all the contacts. So there you have a list within a list. And to illustrate that here in code, I created this list and I called it number names. And we're going to look at the names of numbers in a few different languages. As before, we have to define that this is a new list, and we have to repeat our data type. And then we're starting this as an empty list with a pair of empty parentheses. And then we move on to actually populating our list. So here's where things start to get a little bit involved. If we were to break down this whole line bit by bit, we can see that here at the beginning, we're just talking about our number names list. And we're using the add method for lists to add something to it. But here we have to add a list into our list. And now we're using a direct way of creating a list with values in it. And you'll note that in this case, even though I have to define that it's a list and that the data type is strings, I don't actually have to give this a variable name. I'm creating a list here that already belongs in something else. So I'll have another way to refer to this one, as we'll see in a couple of lines. And then as before, I use the curly braces to say that I am going to actually provide this list with some text values. And I give the English equivalents of 0 through 4. On the next line, I do pretty much the same thing again, although now I'm giving the Spanish names of 0 through 3. And one more time, I add a third list in here, and this is a list of the Mandarin names of 0 through 1. I'm sorry, 0 through 2. I don't actually know Mandarin. I had to Google for that information. And now that we've added some stuff into our list, we can verify how big that list is. So previously, we used size, and we're doing that here again. And because we're calling size on number names, it doesn't care about all of the really granular stuff. It really just wants to know how many lists are there in our list. Well, we added 3, so I expect there to be 3. And of course, this being an assert equals, if I run this, it'll pass. But now we want to start to think about, well, how do we get at those lists that are inside of our list? And the way we do that is, well, really, it's just like we were doing before up here when we were trying to get at twine and thread. We use the index. So each of those lists inside of number names is given an index. And on this next practice, you'll get a chance to practice with those. So on this first one here on line 38, we can see that we're talking about the item at index 2 in our list. Now if we count from our index of 0, we can say, well, this is the item at index 0. That's the first list we added to our list. This is index 1, and this is index 2. And so what we're trying to do is get the size of that list inside of the list. Well, there's 3 items in there. So I bet if I put a 3 in there and save that and run the test, let me go ahead and reorder my test run here. There we go, that most recent one clears. So indeed, we did identify that this is the list at index 2. And for our next practice, we have flipped it on its head. We say, well, we expect a list with 4 items. So now we have to look through our list of lists here and find which of them has 4 items in it. It's this middle one in Spanish here. There's 4 text strings in that. So that's 0, 1. That's the one at index 1. So we'll go ahead and put that in. Save it. And we'll give another run as soon as the saving finishes. And sometimes the saving takes a little while here. Or a long while. Hopefully this isn't indicative of some new Wi-Fi issue I'm having.
It just happens. The console has its quirks.
Well, Gothamist.com comes up fast, so looks like it was just like Ohad said. Sometimes it takes a little longer, but it did save. And I'll go ahead and run the test. And now I'll demonstrate one of the annoying bugs about the developer console. Even though I've sorted my test runs from the most recent to the oldest, well, when I run a new one, for some reason it always puts it at the bottom. So I'm going to have to resort here to get that one at the top to verify that line 39 also passed the test. So now we've shown that we can work with those lists inside of lists and use the methods just as we had before. What if we want to get at the actual items within those? Well, it's pretty logical because this is code and it's all about logic. So what we do is we just double up our index references. So what we're doing here in our system assert equals is we're once again calling that number names list. And then we say, first off, get the item 0 from number names. Well, that would be our first list here. And now we have another 0 here, and that means get the first item from the first list, or the first item from the first item, in which case that would be 0. Now, I probably have done everybody a disservice here by using the word 0 and the number 0. That's perhaps not the clearest way I could do. So maybe if instead this were something like, how about Z? It would also work just the same. But we can keep stringing these indexes on, or we can start, from this point, we could even start using string methods since we know that we have a string. So similar to dot notation, with these indexes, you can just keep adding more things onto them and getting further functionality all on one line. Our next example here for practice, this one's a bit more complex. And this is a chance to practice concatenation. So going back to our data types session, this one is asking you to start with an expected value, the text phrase uno, dos, tres, and to use the values from our numbers name list to actually build that from using index notation. So if we were to do that here, we of course need to start with the name of our list. And then we have to think, all right, uno, dos, tres. So these are from the Spanish list. That is the second item, so that means it's at index 1. So we'll start here and say, all right, we're going to be working with the values in index 1. And now we want the text uno. So if we were to look at our string, well, uno happens to be the value at index 1 in the list at index 1. And now next, moving along, as I concatenate this, I have to use a plus. That is the operator when working with text strings that says concatenate. And if we look at that, what we're expecting, well, it's expecting there to be a space. So I actually have to put in that space and then proceed on to get dos. So here I'll reference number names again, and we're still talking about the list of Spanish names. But now we are working with the text at index 2. And then once again, to get to trace, I have to first put in a white space and then resume my concatenation and get our final element here, still working from that same list. And now it's the element at index 3. So if I got all of that right, I'll save it and run the test. And reorder my list here, and there we go. So we are still passing. This is definitely a good one to practice on your own, and perhaps try other variations with this to really get the concept down of that indexing. You'll be really glad you did when we start working with our next session about for loops, when we really start to step through our lists using indexes. So as I said earlier, lists are the default type of collection that comes from a SOQL query. And here we have an example of doing that. So once again, we start by saying we have a list, but this time I'm saying this is going to be a list of profiles. And as before, I give it a name. I'm just going to call it profs. And now I can, instead of actually having to declare my list, I can just move right into my SOQL query. And we'll have a much deeper look at SOQL queries in our next session. But this one should be pretty intelligible. It's simply saying select name from profile. And just by doing that, Apex knows that if it's doing a query, it's expected to create a new list. So we don't actually need to go to the trouble of saying new list, profile, and then populating it. Now you actually can do this. I think this will compile and the same result will happen. But it's nice to be able to leave that out and just go to the shorthand. But we'll run our test here just to make sure I wasn't giving you a load of hooey. Yep, see, that works just the same as if I didn't have that out there. Unfortunately, you can't always do that with other things. But when it comes to SOQL queries, there's this nice way of doing that.
And just as a kind of a comment, the reason you can do it without the new list part is because a SOQL query returns a list always. And so when you create a new list on the left side, you assign a list to it. So you have to populate a list into what you defined on the left side. And because the SOQL query returned a list, you can just assign it into it. It's just like if you already had a list and you create a new list and you just assign the same list to it. So hope I didn't complicate it more, but that's the reason.
Oh, thank you. Now, I've switched from using system assert equals here and switched back to using system debugs. And that's because I wanted to also take an opportunity to look into the logs and start taking a look at how lists appear in the logs. Unfortunately, we do tend to spend a lot of time in our development looking at the logs. So every time I have run the test, it's created a log file here. And if I look at that line 49, I can see that I put in here the text phrase, all the profiles. And so that'll make it a little easier for me to find it in the debug. So I could simply type in all, and as soon as I start doing that, it starts reducing it down until I get to just the line that I had used that text in, all the profiles. And if we look here, we can see some values that are probably pretty familiar to anyone who's been in the declarative interface. We've got our system administrator and our chatter-free user and on, lots of other profiles. As a convenience, the query also returned the ID of each of those. Even though I only requested the name, it's always going to give me the ID as well. So we'll take a look a little later at some more debug as we get into sets and maps, and we'll contrast them with what we just saw here. As I point out here on this next line, what I just pointed out looking at the debugs, even though we didn't add ID to the select, it was retrieved. But because we did retrieve the name, we can get that as well. So if I were to do a system assert, and check that system administrator was returned, I would just reference my profs list. And from looking at the debugs, we saw that that was the first item there, so I'll call that index 0. And now here's where things get a little bit unexpected. What I'm returning at this point is actually the whole profile. And I need to be a little more explicit if I want to get the name. So I'm using my dot notation to say, get me the name field. And hopefully I don't have any typos in that. And we're going to save that and run it. Look at my test tab, resort that. Yay, it worked. Now, if I tried to get something else from the results from that query, something that I didn't include in my query, like let's see, what's another field on, what's another field that we have on profiles? Anyone fields on profiles. Oh, I know what I'll do. I'm going to go ahead here to my file open and choose objects. Scroll through this.
You can
or
search
maybe just take the
on the
shortcut.
bottom. Yeah.
There we go. And look, it's all of the fields on my profiles. So I'm trying to give an example here of something that we didn't include in our query, and boy, they're all long. How about user type? All right, so I'll go back over here and say, give me, actually I'm going to do a debug. I'm going to say, what's profs 0 dot user type. I'll have to change this from assert equals to debug. We're just really trying to force an error here. Now at this point, it was able to save because what I did is not incorrect. There is a user type field on profiles. But if I run the test, when it runs that code, I get an angry red X. And if I click on this, I get this method that says, S-object row was retrieved via SOCL without querying the requested field. And it's just telling me you can't get the user type because you didn't ask for it earlier. So we'll take a lot deeper look at that in our section on SOCL queries next week.
I can just add and promise you that as you start developing, this is one of the errors you'll be experiencing a lot. As you start with something and add functionality to it or do add fields to a page or whatever, suddenly you realize you didn't ever query that field you're trying to show or change. So yeah, that's a good one to get introduced to.
And I had put in here so that I wouldn't have to do all that searching that I just did. I had actually put in an example with created date. Same thing. Well, let's go ahead and skip to this next practice. And in this case, we are looking at trying to figure out how big that list is. So theoretically, you could since we don't know how many profiles there are in this org, you could go to the logs and you could try and count them all, but I think you'd probably lose track. And actually, it doesn't even include them all. This ellipsis here tells us that it gave up on including all of them. So probably the most effective way to do this is just to do a system.debug on profs.size. Now I'll have to comment this line out because it's not ready yet. But now when I run this, that debug statement's going to tell me how many items are in that profs list. So if I go over to my logs and I pop that open, and I start scrolling through, and I realize, geez, how am I going to find that? There's a ton of crap in here, and I didn't give myself a nice friendly name to search on. Well, there's a couple ways you can do this. You can winnow this down by clicking the debug only, and that's going to return all of the debug statements, but you can end up with a lot of those. So another way you can get there is you can go back and go, what line was that on? Well, that's line 59. And I can just filter on line 59, and there it is. I now know there's 36. So sometimes you're using debugs really to, while you're coding, to give you some information that would otherwise be hard to obtain. And I'll go ahead and put that in and save it, and we'll give a test run to make sure I haven't broken anything yet. And now it's back on track. All right, so we're just about done with our description of lists here, and lists are the one that I really am emphasizing the most tonight because they are so common. I will breeze through sets in about 15 minutes, and then we'll work our way through maps at the end. But one last thing I want to mention about lists here. There are some other formats for creating them. I don't recommend using these. They're not as friendly, and other coders who use them are trying to somewhat either save some characters or be obscure or just type as little as possible. But what we've got here on line 64 is another means of creating a list of strings. And this one kind of turns it on its head by defining the data type first. It says these are strings. And then rather obscurely, it just has a pair of empty angle brackets. Well, that is a shorthand for saying a list. And then we get back to normal and we say, well, we have to give that list a variable name so we can refer to it later, and that's one word. And then what we have here on the right looks a little like what we saw before. We have to tell Apex that this is going to be new, and then we have to repeat ourselves and say it's the string data type. But now we've got another option for working with the string. We can actually limit the size of that list when we use this style. I can say this list only has room for one item. And that means that we can only put one string in there, which is exactly what we do on line 65. Here we kind of go back to our index notation. So here the 0, instead of telling us how many items can be in there, is just saying at index 0, enter the string able. And that works fine until we say now take that same list, one word, and at index 1, put the string baker. So if I save this and try and run it now that I've uncommented that line, we're going to get an error that says list index out of bounds. The out of bounds here is the compiler's way of telling us that the reference we made to index 1 doesn't actually exist in this list. Now you're actually going to probably encounter this same error message when you're coding your own lists, when you perhaps are running through a list and the list has, say, 9 items and you try and get a 10th item from it, and you're going through your loop and it gets to the 10th item and it says there is no 10th item. It's going to give you this same list index out of bounds. And usually you have to go back and look and ask yourself, why did this try to go to 10 items when there's only 9? But we'll take a look at that when we get into for loops. So I'm going to go ahead and comment that back out, since we know that line 66 was causing things to fail. But we'll take a look at here. There is a way to get around that. Even though I can't say at index 1, put a word, I can actually go back and say, well, add something to this list. And when I do that, it will, in fact, let me expand the list from only one item to two items. And I do a system debug there to return that. And then I actually go back and make a reference to that, the item at index 1, and now I change it to Baker, to another word, and do another system debug. And finally here in a system assert, I'm just confirming that there are two. Really, all of that is mostly with the intention of helping you read other code you might run into out there. If you're looking on Stack Exchange and you see this format here, I just wanted you to be able to stop and think, I've seen that before. I've seen those empty brackets. And that means somebody's creating a list. So don't recommend using it yourself, but it is out there, and now you know just a little bit about it. All right, before we move on to sets, I wanted to take a pause here and ask if anyone has any questions about lists, or if any questions came up in chat that Jonathan or Ohad think are worth revisiting.
Chat has been suspiciously quiet. I think that either everybody has been extremely interested in listening to what you had to say and you were very good, or people fell asleep, one of the two. I think you did a very good job explaining. It was very easy for me. Of course, I know what you're talking about, but it was very easy for me to follow. I think you introduced some, relatively complex concepts to people that don't have experience in programming. So it kind of required people to really pay attention to what you're saying to be able to keep up. So I'm guessing because of that, people were really not asking a lot of questions, and I think you did a really good job explaining, so it didn't prompt them to stop us with hey, what does that mean?
And we can assume that the chat is working because we've had absolutely no technical issues so far today.
Yeah. No, but Jennifer and Hema are talking here, so it does look like it's working.
Good. Good. All right, well, let's move on to sets. So sets are a lot less commonly used, but they definitely have an important place in our collections trio. Sets, unlike index or lists, are an unordered collection. That means all of that talk about indexes and starting at 0 and so forth, totally useless when it comes to sets. You don't use that at all. What are sets for then? Well, sets force uniqueness on their contents, on the items that you put into a set. And that is particularly useful when you are working with things that are unique IDs. So we often use the data type of IDs when we are playing with sets. There are also a couple of useful methods that sets provide that we can't do with lists, and we'll take a look at those very shortly, but let's jump right into how we create a set. So it's a pretty familiar pattern here from looking at lists. We have that same left and right behavior where we say we're creating a set, and we tell it what data type, strings again, and we give it a name, planets. And then we even use the same curly braces to populate our set with some values from the get-go. And just like lists, we have a size method that'll tell us how many items are in that set. But now let's take a look at how sets start to differ from lists. So once again, I create a set called months, and I start this one out with nothing in it by using the empty parentheses. And once again, just like lists, I have the add method for adding values. So I add June, and then I add July, and then I add June again. Now, if we were doing this with a list, we'd have 3 items in our list now. But because this is a set, it already knows that June is in there, so it doesn't add it again. And in fact, when we do our system assert equals and check the size of that set, it's going to return that there's only 2 items in there. So it doesn't throw an error. It's perfectly fine with you attempting to add the same thing again. It just says it's already in there, so move along. And then the other useful feature that sets have is that they have this method called contains. And this is a lot like the contains that you've seen elsewhere in formulas or in reports, that it allows you to specify a string, and then the contains is turning a true false. So it's going to look at all of the items in our set called months, and if there's an item that matches, it is going to return true. And if we really wanted to, once again visit our autocomplete here, it's always useful to be able to decode what we see here. We can see here's contains, and it's saying, well, you can put any data type in, and it's going to return a Boolean, a true or a false, when it runs that method. Now we do have to put in a data type that makes sense here, that matches what the set has. Otherwise, we get the angry problem circle, and it's telling us that I'm using an incompatible element, an integer, when we're talking about a collection of strings. So I'd better change that back to a string, which means I better put it in single quotes. I'll go ahead and save that. And as I said, we use this a lot with IDs. And that's because usually in Apex we are working with our records from the Apex triggers, and we're working with the IDs of those records that come through. And a lot of times we might end up pulling in a couple of lists of IDs, and we want to make sure that we don't have any duplicates in there. And so I've created two lists here, one on line 96 and another on line 100. And if you eyeball these, you can see that in each of them there is a duplicate ID. They also have two unique IDs in each. But we want to end up building just one list that has all those IDs without any duplicates. So after I define that list, I go on and I create my set. And I call that, I say that's going to be a set of IDs, and I'm going to call it set A. And once again, I say it's a new set. And here's a handy way that you can actually populate a set from a list. I can just make a reference to that list right there, and that automatically puts everything right into that set. Now, just to make sure that the variable naming is clear, and this is sort of jumping off onto a sidebar tangent here, I'm calling this list 0. I can call this anything. I can call it Ernie. And I just have to change it wherever I'm making a reference. So previously it was list 0. Now it's called Ernie. Same difference. And so now at this point, I'm pretty sure that those 3 items are in there, so I'm going to move along. And I'm going to set up my second list here, and I've got some IDs, and one of them's a duplicate. And in this case, I'm calling it list 1, but I'm going to go ahead and change its name to Bert. But as soon as I save that, because I forgot to change it here, I get this error that says variable does not exist, list 1. And that's something you'll probably see a lot too as you work through your code. And that's just telling me, well, you never defined a list 1. So you either need to go back and define one, or if you know what you're talking about, change it to whatever you know it should be. So there we go. Now I did the same thing here as I did on line 97, but I used a different method. In this case, I said set A because I already had it created, and I can just say add all and feed it my list. So at this point, I've fed it these 2 lists. And there are 3 items in each list, 3 IDs in each list. But at this point, if we really take a look here, we're going to see that there really are only 5 items in that list. Let's go ahead and run a system debug on set A. I better re-comment that line, or it'll complain that I have something in there that makes no sense. Oh, I forgot a period. There we go. And let's go ahead and run our test here, and then we'll take a look at our debug log. Now, I notice this is on line 102, so when I go to my logs, pop that open, I'm just going to type 102 into my filter, and it takes me right there. And we can see the output from our debug of that set. And if we look at this, we can see there are, in fact, only 5 items in there now. So even though we added 6 items, it knew that one was a duplicate and just immediately skipped over that duplicate. And here on this next practice, we're just going to write a full system assert here to verify that we did, in fact, get all of the items from those 2 lists. So I'm going to start by calling my set A. And then I have this really nice function here called contains all. So before we looked at contains, and we were just looking for the text July and just looking for one item. Now I'm going to say that I wanted to confirm that it contains all of the values in the list I called Ernie. And I'll go ahead and save that and run the test. And there we have that latest test. It passed. Now, if I also wanted to know that it contains all of the items in the other list called Bert, I could really just do some very short work here and just put two Booleans together with an and. Yep, what did I get wrong? Can only be applied to Boolean expressions. Aha. All right, let's see here. I know what I need to do. I didn't even write this as a system assert. So this is a system assert, not an assert equals, because we are working with Booleans. And what I meant to type in there was set A contains all and Ernie. And what I had previously done when I did set all contains Ernie, by not putting it in a system assert, I wasn't really testing that things were working. I could have had a complete failure and it would not have told me. And that is why we use system asserts. So in this case, now I should have gotten a valid test. And now I can move on to showing you what I was trying to by using a pair of double ampersands and say set A contains all of Bert. And we'll go ahead and run that. And once again, it passes. So even though I can essentially do multiple tests in here, this actually is not a particularly good way to do your unit testing. Because if this line were to fail, I'd actually have to go back and check both of them to see where it failed. So it really is best to break your system asserts into as discrete elements as possible. So I'm going to do that here. And so I'm really getting the same behavior. I'm checking both of those lists. But by having it on separate lines, I'll know exactly which one failed. And so when we revisit unit testing, we'll really be looking very closely at how to really efficiently unit test, because it's once things start failing, you really want to be able to get down to where it's failing as fast as possible. So that's all we really had to say about sets here. As I said, you don't use them all that often, but when you need them to get that guaranteed uniqueness, they are invaluable. And they also prepare us to segue into maps. Before we do that, I'll welcome any questions or any input from Jonathan and Ohad.
I have nothing to add at this point, believe it or not.
All right, here we go. Maps. Maps are one of the things that I didn't use for my first 2 or 3 years of writing Apex. I knew they were there. I saw them. I didn't know what they were for. And when I finally learned how to use them, I realized, wow, this is a really powerful tool that I wish I had known about. So that's why we are introducing it here and now so that you will know about it. Ohad just posted a question. Are variable names case sensitive? No, they are not. I was being a little fussy about my typing and trying to be precise about that. But as you can see here, I referred to lowercase b BERT when I had defined it as uppercase B. So no, they are not. There aren't too many places where Apex enforces case sensitivity.
What I would say is this, even though variables are not case sensitive, there definitely are some best practices or common practices that people use to identify variables, and different people have different preferences on how to do that. And but when you start to work more with variables and you start programming, you want to make sure that you give your variables names that have meanings. And so and as we go through this, we'll probably make some more comments on this, but there is some use of case to make it more readable, but at the same time, case is not important, meaning you could, use it one case in one place and another in another, and just like Luke was showing, it would work and it would be the same variable essentially.
And there definitely are some conventions that each different programming language has. Apex kind of follows Java conventions. And I try to demonstrate them here, and I certainly would appreciate if anyone in the know would point out ones where I haven't, and we'll make that correction as an additional learning moment. All right, on to maps. So maps are a compound collection. And by that I mean that every item in a map is made up of 2 data types. And as you can see here, when I define this map, I'm feeding it 2 data types, a string and another string. These 2 data types are called the key-value pair. The first data type is the key, and the second data type is the value. As before, I give my map a name. I call it field values, and tell Apex I'm creating a new map with a string and a string as the key and the value. And then I start defining some of the items in there. And once again, we use our curly braces as we did with the lists and sets. But now when I put items in, I have to put 2 items in at a time. And the way I do that is I define my first one, the key, name, and then I use this equals and greater than, which are not actually behaving as an equals and greater than, but really kind of behaving as an arrow. And I give it the value. The name is 2U Inc. And then a comma tells me that I'm starting on my second item. And here I have a key of website and a value of 2u.com. And move on to my third item, phone and the phone number. Now that's a phone number as text because even though phone numbers are numeric, they really are text. You can't add two phone numbers and get another phone number. So now we get back to something a little more familiar. We're able to use our system assert equals to verify that there are 3 items in this map by using that size method. And just like lists and sets, we have a whole page of documentation, all the methods that we can use with maps. And we will quickly find one that is something a little different than our lists and our sets. So now we're taking a look at creating an empty map. And this was a lot like creating an empty list and an empty set. We do our regular definition. In this case, I'm saying that the key is going to be an integer, and the value is going to be a string. But then I go back to the pattern of having a couple of empty parentheses to say it's an empty map to start with. Now with lists and sets, when we wanted to add items to it, we use the word add. For some reason, here in maps, we have to use the put method instead of add. And we have to, of course, give it the key and the value. But when we use put, we don't use the equals and greater than. We just give it 2 items. And they do have to match by data type. So I give it the integer 1 for the key and the string ye for the value. And really what this means is that these 2 things are forever related in this map. And that way, when I later need to check what I have in the map, I'm able to use, as we see down here, the equivalent of put for get. And that will get, when I feed it this 1, it's going to go ahead and get whatever the key 1 equals. So that's going to return ye. So one way I like to think about maps is that for the keys, you're putting something that you know. And then for the value, it's something that you want to know. And here I'm particularly using a very specific example. I don't know Mandarin. I'll never be able to remember what the Mandarin word for 1 is. But I'll always be able to remember.
Don't sell yourself short, Luke. You'll be able to remember.
I think actually ye might be 0. Or maybe I'd have to go back and look at my list that I did it. So, but I'll always be able to remember the integer 1. And that way, when I'm working with my map, I can say, well, get 1. And it's going to return whatever I had put as that value. So we go on. I add a couple more items into my numbers list. I do 2 and and 3 and san. And I apologize for any mispronunciations of Mandarin here. I guess I could make a map of pronunciation for these and do a string to a string map and put ye as the key and the pronunciation as the value. So let's take a look now at this debug here and see how that came out in our logs. I probably can just go to a previous log and hopefully find that at line 126. Yeah, maybe not. I'll do this the hard way, because sometimes you have to. So I'm just going to scroll through here, and this is something I do tend to do a lot. There it is. I guess I added a few lines of code. So I can see that previously this was on line 121. But I can kind of recognize that the debug output did in fact return ye. I suppose a shorter way for me to have found that would be to check my debug only, and then I have fewer things to look at. Okay, so once again, I have a quick practice here to help us get used to the use of maps. So I say, let's use our system assert equals and figure out how we get, if we want the value of her, what do we put in our get statement? Well, if I look back here, the key for that is 2. So if I get 2, it should return her. And now on the reverse, if I get the key 3, well, there it is, san. I'll save that, and I'll give this a quick run to see if I'm still on track here. And it looks like that's passing. All right, so now we get into the interesting part of maps. So we already said that we have keys and we have values, those key value pairs that each item in a map is made up of. But there's also another dimension to maps. We can think of the maps as sort of a matrix. If we look back here, well, in addition to each of these items, there is also this vertical component, all of the keys. The keys are 1, 2, and 3. And there are the values, yi, and san. And if we want to get just the keys or just the values, maps provide us with a method called key set. And taking a look over at our log, our next debug here indeed shows us that the key set, when I use a debug, returns 1, 2, and 3. And that is very specifically named a set because maps do treat the keys like a set. In other words, they must be unique. And that's because if you had 2 keys that had the same name, you wouldn't be able to get them. So if I tried to put in a second instance of 2, it's going to compile, but all it's really going to do is just overwrite what I did previously. It's not going to put in a third key value pair where 2 is, has a value of san. I better fix that back. So it will enforce that uniqueness on the keys. And that is a very desirable attribute of maps because it really means that we can very confidently use get to get exactly what we want out of our map. Then on the other side, the values, we've got the values method. Very, very friendly name for it. And that would return just what you would expect. Let's go to our logs and pop that open. And my debug only. And oi, it brought back a bunch of IDs. Where the heck did those come from? I was expecting yi, san. What did I put in there? And now we're going to have a quick lesson in debugging. So that's really strange. Is that fact line 133? No, that's line 102. What do we got going on here? Let's check this again. Oh, I bet I didn't run that test. Now let's see. There it is, line 133, the values from our map, numbers, yi, and san. And each of those does come back as a set and a list, and we can use all of the functions that we've already looked at with lists and sets on either the key set or the values. So we can reference each of those values with an index. We can use contains on the key set and really manipulate those a little more distinctly. And so for our final example here, for our practice here, we're going to have some chance for you to practice both creating a set and a list and comparing them to the map that we have. So in this first one, the instructions are to populate the set below that I've named my numbers with the items that will make it pass this system assert equals. So what we have here is we're saying the numbers in the key set, pretty much what we saw right up here, should equal this set of integers called my numbers. So let's take a look at how we would do that. So here we have our set integer, and I need to say I'm going to create a new set here of integers. And I need a curly brace if I'm going to populate my set. And these are integers, so I'm just going to skip the single quotes, and I can just put in the numbers and save that. And it's saying I forgot something. Oh, I called it integers. There we go. I got the data type wrong. Now it saves. I'll go ahead and do a test run here to make sure that that change worked. And that passed, so we'll move along. Now we're doing the same thing, but for the values. So I'll say new list of strings. Nope, of string, not strings. But now I do have to use text, so I have to use my single quotes. I think I'm setting myself up for failure by way of an example here. I'm pretty sure at this point we might be in one of those situations where it's going to enforce some case sensitivity on us. Let's see if that passed or failed. Indeed, it did fail. So either I can't remember my Mandarin, yi, er, and san, or it actually is enforcing the case sensitivity. So let's pop open our
I believe when you
test
compare
here.
strings, the comparison is case sensitive.
Exactly. So we can see if we look here, it's expecting yi, er, and san, but because I did not honor the case sensitivity, it is calling foul on that. And I could either go back and try and correct that, or another thing I can do, well, let's see, this is a list of values. I was going to try and use to lowercase. That might be a little bit excessive at this point to go through and do each of those. So I'm just going to fix these here. There we go, yi, er, san. And give that test another run. And now it does pass. So that is one area where we do see case sensitivity mattering. Sometimes when you're coding around that and you can't really predict what's going to happen, we'll use the string method of either to lowercase or to uppercase to perhaps account for user-entered data. So if we were doing something, say, with a visual force page and we're expecting the user to enter their name and we want to compare it with another value, we might end up just casting everything to lowercase. That way we don't have to worry about the case sensitivity. We're really just concerned, do these strings have the same letters in them in the same order? All right, so we've just got a couple of other practices here, and I'm actually going to leave those to you to do a little research. These expect you to go out to the map class and find a couple of methods there to get those asserts to pass. And at the beginning of our next session, we'll actually go back through some of all of the fix-me's here and we'll take a look at them so that people can ask any questions they had, or if they had any interesting errors, we can share them and debug them. And the map class that I'm talking about, I'll pull that up onto the screen here. That is the Apex Developer Guide for map class, and you'll want to look for the methods there. And just a little helpful hint here, whenever you are looking for elements about Apex, it is a good idea to include the word Apex in your Google search. I have an example here where I did a Google search for list class without saying Apex, and you see I start getting things from Oracle, about Java. I start getting things from Microsoft, probably about C++. But as soon as I put in Apex, it pops right up to the top of my list. So when you are searching, it's always a good idea to include that, or perhaps Salesforce, to make sure that you're not having to scroll through too many pages of Google results, because a lot of these names are very common. Certainly can open it up to questions now, or any advice from Ohad and Jonathan, or anyone about working with collections. And certainly if you have questions as you're reviewing this later, you can feel free to email me, and I'll hopefully be able to answer those, and we'll revisit them at our next session. And
the only thing I would like to say, Luke, first of all, I think you did a great job going through this, and the exercise, I think, is do a great job at illustrating how you use collections. But with that, I'd just like to make a quick comment and say that, I definitely recommend everybody here to spend the time between now and the next session to go over this and really try it as much as you can to understand exactly, how these collections work, what is the difference between a list, a set, and a map, and at least try to somewhat familiarize yourself with some of these methods that are available to you. The reason I'm stressing collections so much is because as we start actually developing and as you start going through development, collections are one of the tools in your toolkit that you'll be using all the time and a lot of. So understanding them, the sooner you understand them, the better you understand them, the easier it will be to kind of get into it as we start to get into more complex things. That's all.
And really, conceptually, these are all things that everybody's worked with in the declarative in our reports. I started out by saying that list views are kind of a list of lists. Well, to be more precise, now that you've seen maps, you would be able to recognize that a list view is actually a map. You're never going to get a duplicate row in there. You're never going to get the same record twice. That's really because it's a map there, and it's enforcing that each of those rows is just one lead. And then across that, you have all of the key value pairs. Those are the fields and the values that are in each of those leads. So conceptually, this is all stuff you're already working with all the time. Now we're just looking at how it looks in Apex. And with that, I will say that our next session will be about SOCL, because SOCL and collections go together like, keys and values. And I have a survey in this for this session. So when you get the post-meeting archive email tomorrow, I would love to get feedback about whether I'm going too fast or too slow, or other things you'd like to have more of or less of.
Awesome.
Thanks, everyone, and I'll see you out in the cloud and next week in the webinar.
Bye-bye.
Good night, everyone.
Thanks. Bye.